Once I've found both of these equations, I now have to set them equal to each other to find the intersection. So that means I'm going to do 3x minus 15 equals negative 1/3 x plus 34 over 3. You can use your numerical solve. Also, if you want to solve for this algebraically, focus on the things that stress you out. I'm assuming that the thing that stresses you out the most about this problem is that they're all over 3, that there's a fraction everywhere. So in order to get rid of that fraction, if you just multiply every term by that denominator, you haven't fundamentally changed the equation at all, but now you still have something without fractions. So if I multiply everything by 3, 3 times 3 is 9, 15 times 3 is 45, negative 1/3 times 3 is negative 1, and then 34 over 3 times 3 is just 34. And now I've got it in a form that seems a little bit nicer to solve for when there's no more fractions. I'm going to add x to both sides and add 45 to both sides. And I'm going to divide by 10. Once you have the x value, you can then go back and find the y value. You have two different equations you can use to solve the y value. Go ahead and solve. You should get that y equals 8.7. I can plug in 7.9 for this guy and do 3 times 7.9 minus 15, and that should give you 8.7, which is your y. Also, if you plugged it in for negative 1/3 and then added 34 over 3, you should have gotten the exact same thing. Which means that your point, your coordinate of D, which is the point where the Roomba should turn and go to the charging station, is 7.9, 8.7. And that is your final answer. Okay, last example for today. Two towns are located at point A and point B, and a nearby road R is a straight line with an equation there. A new taxi firm wants to find a location for a taxi station on the path R, so the taxi stand is equal distances away from both A and B. What line represents the set of all points that are equal distances away from two other points? Hopefully this rings a bell, that the set of all points that are equal distances away from the endpoints of a segment is the perpendicular bisector. So if I wanted to find all of the points that are equal distances away, really I'm finding the equation of the perpendicular bisector. So to answer this, it's the perpendicular bisector. Okay. So we want to first, what's going to happen is that if we want to find a place to put our taxi stand that's equal distances away from both A and B, we don't want to be like closer to B or closer to A, we want to be equal distances away, is really what we're talking about here is the perpendicular bisector. So if we could kind of just sketch in the idea of the perpendicular bisector, which again, we should start getting familiar with it, we can kind of give ourselves a frame of reference for where we might think, not my best perpendicular bisector, but you get the idea, where we might think that this intersection might be. That this point will be equal distances away from A and away from B. So this segment and this segment are equal. Okay, so we want to find this guy right here, and that's the general idea. We're first going to find the slope of the segment that connects A and B. So I want you to find the slope of this segment right here. You should have gotten that the slope is 1/3. You could have either used your 2 points and plugged them into the formula, or you could have counted that I go up 2 and over 6, which means that it simplifies down to 1/3. If I'm finding the equation of my perpendicular bisector, that means that I know that my perpendicular slope is going to be the negative reciprocal, negative, and then 3 over 1, or in other words, 3. We now want to find the midpoint of this segment. Go ahead and do it on your own. The midpoint is just the average of your 2 points. We're going to find the average between the two x's and the average between the two y's. So the x values are 2 and 14. To find the average of them, we add them together and then divide by how many we added. For your y values, that's 20 and 24. So then 2 plus 14 is 16, divided by 2 is 8. 20 plus 24 is 44, divided by 2 is 22. And that is the midpoint of our segment. Now we want to find the equation of the perpendicular bisector, which, hey, we've done all of the work that we need to do in order to make this perpendicular bisector. I would like for you to do this on your own and fill in the blanks for the parts of the perpendicular bisector. Since we have a point and we have the slope, which is -3, and then our point is 822, I'm going to use my point slope form. I'm going to distribute -3 to both terms. Plus 24 because a negative times a negative. And I'm going to add 22 to both sides and get y equals -3x plus 46. I now have the equation of my perpendicular bisector. We are then going to find the point of intersection between the two lines. To find the point of intersection, we need to it's a system of equations. So to solve for systems of equations, we isolate one variable and then plug it in for the other. And a way that we do that is we isolate for y and then set those equations equal to each other. So I've got y equals -3x plus 46. The equation of my line R has been given to me as -x plus y equals 4. So I want to isolate for y here so I can set these equations equal to each other. Since it's a -x, even though it's being added here, I would add x to both sides because it's really the idea of subtracting x and adding y because the sign always goes with the thing after it. Okay, so in order to undo this -x, I add x to both sides. Once I've gotten to this point, I now have my ability to be able to set these equations equal to each other and find the point of intersection. Go ahead and do so on your own. Setting these equal to each other looks like taking this piece and taking this piece and putting them in an equation together. -3x plus 46 equals x plus 4. I'm going to add 3x to both sides, and I get 1x plus 3x is 4x. I'm then going to subtract 4 from both sides and get that 42 is equal to 4x. I then divide both sides by 4 and get 10.5 equals x. Once I have my x value, I'm still looking for a point, which means I need my y value. I can plug in 10.5 for either this guy or this guy. I think this one's easier because I just need to add 4 to get to y. So then 14.5 is equal to y. You should get the exact same thing if you plug it in for here. My point where the taxi stand should be is 10.5 and 14.5. The last part of your problem-solving process is prepare and then solve. The last part should always be assess. Go back to the drawing that we did at the beginning to kind of generalize this. We said, okay, well, it would be the set of all possible points that are equal distances away from two other points is the perpendicular bisector of that segment. And we know that then the point on this line that would be equal distances away from A and B is going to be the intersection of the perpendicular bisector with this point. Once I drew that in, I had a general idea. And notice that the point 10.5, 14.5 is really close to this point, if not that point exactly. So we did a pretty good job of kind of guesstimating here of like, okay, it's going to be about around here. And then our answer down here makes a lot of sense. That is in the same range as our visual guess of the situation. So taking a step back and saying, does this answer make sense? Yes, it does. Is the ending to a problem-solving process. Great job today.